Welcome to Spring LIB.
For this problem on the topic of oscillators, we are told that a freely hanging spring has a mass m, which is gently placed on the end of it, and the mass is then allowed to fall 32 centimeters before it comes to rest and begins to rise. We want to know the frequency of this oscillation. Now, if we consider energy conservation for the mass over the range of motion from the highest point, when it is let go, to the lowest point, the mass falls the same distance that the spring is stretched and has no kinetic energy at either endpoint. If we call the lowest point the zero of gravitational potential energy, and variable x here represents the amount that the spring is stretched from the equilibrium position, then by the conservation of mechanical energy, we have the mechanical energy at the top of its motion must equal the mechanical energy at the bottom. And this is a half m v at the top squared plus the gravitational potential energy at the top, mg y top, plus the elastic potential energy, a half k x top squared, must equal to the mechanical energy at the bottom of its motion, a half mv at the bottom squared plus mg times the position at the bottom, y bottom, plus a half k x bottom squared. And so this simply becomes 0. At the top it has no kinetic energy, but it has gravitational potential energy, mg capital H. It also has no elastic potential energy before the spring is stretched. And at the bottom, it again has no kinetic energy, and that's the 0 point of gravitational potential energy, so the gravitational potential energy is 0, but it has maximum elastic potential energy of a half k h squared. So essentially all the initial gravitational potential energy is being converted to elastic potential energy. So if we rearrange this equation, we get the spring constant k over the mass m is equal to 2g over h. We know k over m is the angular frequency of oscillations squared, omega squared. This means that the angular frequency omega is the square root of 2g divided by h. And lastly, we know that the frequency f is related to the angular frequency as follows. The frequency f is the angular frequency omega divided by 2 pi. So the frequency f is 1 over 2 pi times the expression for omega above, which is the square root of 2g over h. And so if we put the values into this, that's 1 over 2 pi times the square root of 2 times 9.8 meters per square second divided by the height to which the mass falls, which is 32 centimeters or 0.32 meters, which gives us the frequency of oscillations to be 1.25 hertz.